So I told you yesterday we were done with graphs. So we're not done with signs, we're just done with the stuff on graphs. Tonight's homework is word problems, which means freehand. We saw one of those on the quiz, right? You had a high-low temperature question. So what we're going to do is figure out how to work backwards. Let me start you out with forwards so that you can quick understand what we're doing. Sinusoidal, that means basically a word problem that is a sine. It's a word problem that's got a rhythm to it. It's got a pattern. It's got a cycle. All right, so temperature has cycles. Warm in the day, cooler at night. Warm in the day, cooler at night. Warmer in the summer, cooler in the winter. Those are cycles. The tide, high tide, low tide, high tide, low tide, high tide, low tide. Full moon, not full moon, full moon, not full moon. These are all sinusoidal. Okay, think about your, have you ever seen like a TV show about the hospital or gone to a hospital? Where do you see sinusoidal rhythms? Okay, like blood pressure or your heart monitor, right? Ba-boom, ba-boom, ba-boom. Okay, or if you have if they're monitoring your breath, you breathe in, you breathe out, you breathe in, you breathe out. All of that is sinusoidal models. It just means something that follows a pattern, a cycle. All right, so let me kind of start you out with a sort of easy one. If you've got 5 sine x plus 12, and I say freehand that. Okay, so it's going to look like this, right? I just mean a quick freehand sine graph. What is the high point currently of the sine graph? 5. And the low point? -5. Okay, we call that the range because that's the amplitude. But what does the 12 do? Shifts it up. So we bump that up 12 and we bump this up 12. And what's the new range? 17 is the high, but what's the lower one? 7. 7 to 17. That's forwards. Okay, what if we do this backwards? What if I give you the range and I ask you to work backwards and tell me where it came from? That's the whole point of a sinusoidal model. So let's try that. Let me tell you that the range is 10 to 50. And it's a sinusoidal model. All right, so freehand a sine, and right now we're at 50 and 10. Can anybody work backwards in their head and figure out before it was 50 and 10, what was it? Because it's clearly been shifted. All right, it's been shifted up. Can anybody figure that out to what it was before it was 50 and 10? Think about it, and I'll give you a minute to think. All right, let me help you think about this. What is the gap, or what is the distance between 7 and 17? 10. All right, what about the gap between, between 5 and -5? Also 10. Okay, so the gap between 7 and 17 was 10. The gap between 5 and -5 is 10. All right, well, let's see if we can use that to help us out here. What's the gap between 10 and 50? 40. Okay, the gap between there is 40. How else could we design a sine graph so it had symmetry, right? So you have a positive number and a negative number that are symmetric, but it still has a gap of 40. Okay, divide it in half. And so what would the top number be? 20. Very good. So we want to think it's 20 and -20. Think about this one. Okay, do you agree with me that the gap between 5 and -5 is 10? Half on the top, half on the bottom. Right? 5 up, 5 down. All right, if we are trying to make something that has a gap of 40, I need half to be on the up and I need half to be on the bottom. So if we divide it in 2, we can have 20 on the top and 20 on the bottom. So what number was added to that 20 to make the shift end up at 10 and 50? It was 30 up, right? 30 up on both ends. So what does that tell you 30 is? 30 is the shift. And what does that tell you that 20 is? The amplitude. And so you write the equation y equals 20 for amplitude, 30 for shift. So you're working your way backwards. All right, let me try another one with you. All right, New Mexico. "12-month temperatures." Okay, so January through December. They are as follows: 34, 40, 47, 55, 64. What are these numbers doing? Okay, they are going up. We're January, February, March, April, May. Okay, we're going up. 74, 79. What do you expect the numbers to eventually do? Why? Because that's how we are on a tilting planet, and so yes, okay, so then we go back 76, 69, 57, 44, 35. What's the range? 34 to 79. Okay, 34 to 79. All right, what's the gap? She's fast. All right, the gap is 45. Between 34 and 79, the gap between them is 45-degree gap. So if I am making a sinusoidal model, and there's a 45-degree gap, actually it's a cosine model, because where do I start? I start at the low part, right? Start at the low part, go to the high part, come down to the low part. All right, if I'm making a sinusoidal model that has to have a 45-degree separation, how much on the top half, how much on the bottom half? 20? That would just give me a 40-degree separation. 22.5, right? I need 22.5 here, and I need negative 22.5 there. So what shift will get me from that separation back up to the right range of 34 to 79? How much will get that 22 up to 79? It's a quick little subtraction. You can use your calculator. I'm not asking you how much. 56.5. Does that work on the bottom one? Check it. If I add 56.5, that should get me to what number? Should get me to 34. All right, so I have so far, my amplitude is 22.5, sine x, or sine something, plus a shift of 56.5. Now we got to deal with the parentheses. What is the time period over which this is occurring? A year, which is how many months?
12.
So the cycle needs to be 12. So quickly, how would you force 2 pi to turn out to be 12? What would have to go there to make sure, not just 1/6, 1/6 pi, all right? And so that has to be our b value to force the period to end up to be 12. If you're not sure about that, you can cross multiply to figure it out. You can say b goes here, and then cross multiply, and it works out to 1/6 pi as well.